Good morning, students. Welcome to online class, chemistry class, class 12, electrochemistry. Today's topic is Nernst equation. In this equation, it's actually relating the cell potential with concentration as well as the temperature. What we know that E naught is the standard cell potential that is measured at 1 atmosphere. Here it is 25 degrees Celsius or 298 Kelvin and 1 molar concentration of ions. At such case, we called E naught as the standard cell potential. The variation of cell potential with temperature and concentration of ion is represented by this equation called the Nernst equation. E cell, that is the cell potential measured at different concentration or could be at different temperature, and or either the concentration or temperature is variable or both are variable, that is equal to E naught cell minus RT by NF log concentration of product to the power x, concentration of reactant to the power y. In fact, that is the equilibrium constant. So here E cell is equal to E naught cell minus 2.303 RT. It's a decimal log. NF, concentration of product raised to the power the respective number of moles divided by concentration of reactant raised to the power its respective number of moles. If we consider the temperature at 298 Kelvin, then 2.303 RT by F, which is 1 Faraday or 96500 coulomb, or that is equal to 1 mole of electronic charge, means it is equal to 6.022 into 10 to the power 23 into 1 electronic charge, that is 1.6 into 10 to the power minus 19 coulomb, which is estimated as 96500 coulomb. This as a whole is a constant and is written as 0.059 provided our temperature is 298 Kelvin. So in that case, E cell is equal to E naught cell minus, we can take the approximation 0.059 by N, which is the number of electrons exchanged in redox reaction. For example, in case of process where 2 electrons are lost and 1 electron is gained, overall in the reaction redox process 2 electrons are being used. If suppose 2 electrons are gained and 3 electrons are lost, take the LCM and total 6 electrons are being used. So this form is called the Nernst equation. Let's come to the numericals of Nernst equation. Your 3.5 NCERT numerical, that is given as magnesium solid, phase change Mg2 plus, the concentration given. Double vertical line stands for salt bridge. Then copper ion, concentration given, and copper solid. Now it's my advice to write that all concentration in terms of 10 to the power 3, 10 to the power terms. Otherwise, during exam, you may get a confusion in writing the number of zeros from the question paper, copying this from question paper. So it's better count it and write it directly as I have written 10 to the power minus 3m, and this has 10 to the power minus 4m. Now, as we know that in the cell potential, the left side is anode or where oxidation occurs, and the right side is cathode or where reduction occurs. So the overall cell reaction comes as at anode Mg changes to Mg2 plus 2 electron, and at cathode copper ion accepts 2 electron, changes to copper. So the overall reaction is Mg plus Cu2 plus ionic gives Mg2 plus and copper. The number of electrons used is 2. Now here the pure solid or liquids will not be under consideration of equilibrium constant. So it's copper ion as the reactant and it's magnesium ion which is as the product. E naught cell is equal to E naught cathode minus E naught anode, that is E naught of copper ion, the reduction potential, and that of magnesium as the reduction potential. Seeing the value from the standard reduction potential charge, page number 69 in my book, just check in your NCERT also, this comes equal to 2.70 volt. Substituting the values, E cell is equal to E naught cell minus this Nernst equation. Now while writing the Nernst equation, do write this in the form of reactant and product, and of course the number of moles. Here we have 1 mole of Mg2 plus and 1 mole of Cu2 plus. So here I did not write any par. Substituting the values, we are getting a drop of potential from 2.7 to 2.67 volt. That is, the presence of such ions may drop or may increase the concentration of, may increase the cell potential. Now coming to the next question, 3.5, the next question. Fe2 plus, Fe solid, phase change to Fe2 plus 10 to the power minus 3 m, concentration, salt bridge H plus 1 m, H2 gas at 1 bar, and platinum solid. Now in this case, we have 3 phases: the liquid acid medium, hydrogen gas in the standard electrode potential as SHE we are measuring, and the platinum solid electron with which the iron wire is being connected. So this is our anode or oxidation site, and this is the cathode or reduction site. Thereby the cell potential is, cell reaction is first written as Fe changes to Fe2 plus 2 electron. At cathode, H plus accepts the electron and changes to half H2. In order to balance the equation, we need to multiply it by 2. So overall cathodic reaction is 2H plus 2 electron changes to H2. Or the overall reaction is Fe plus 2H plus changes to Fe2 plus hydrogen. Here H plus is the reactant, but both the hydrogen as well as Fe2 plus is the product. So E naught cell is equal to E naught cathode minus anode, and that of hydrogen is 0 minus that of iron is minus 0.44 volt, or that is equal to plus 0.44 volt. So E cell is equal to E naught cell minus, substituting the values, we will write this as product concentration of Fe2 plus, partial pressure of the gas hydrogen, and concentration of H plus square, that is due to the number of moles of H plus ion. On substituting the values, what are we getting? There is an increment in the potential. So E cell might be less than E naught cell or might be greater than E naught cell also. Question number 4, that is given as, we have in the cathode also phase change. Platinum electrodes are taken in which bromide ion and bromine liquid is there at anode, and at cathode it is platinum electrode is dipped in acid solution where hydrogen gas at 1 bar is continuously bubbled. So this is our anode and cathode, the oxidation site and reduction site. The cell reaction anode is written as 2 Br minus will change to Br2 plus 2 electron, the loss of electron, and at cathode 2H plus 2 electron changes to H2. So the overall cell reaction is 2 Br minus plus 2H plus changes to Br2 plus H2. E naught cell is equal to E naught cathode minus E naught anode, or that is equal to, for hydrogen it is 0 minus 1.09. So overall cell potential is, standard cell potential is minus, which suggests that this reaction is not feasible spontaneously, that is without the help of any external aid the reaction will normally not occur. Anyway, the Nernst equation to substitute, we have the pure liquid will not be taken into consideration. partial pressure of hydrogen as the product, and concentration of Br minus square and concentration of H plus square would be taken. So substituting the values, we will get, here the calculation is also being done. Now for your information, I'm telling you, you will not be supplied with the log table this time. So you will be rather given the value of the log 9 or whatsoever the substituted values will be provided. So accordingly, we are getting that the E cell is equal to a further drop in potential, that is minus 1.3 volt. And this shows that the cell reaction is not feasible. Please go through question number 3 and similar kind of questions. If you find any difficulty, please do ask this in the official WhatsApp group. Thank you.